And we're recording, so any objections, please let me know today by email. I was hoping to share a slide to say essentially what I'm saying now, but since it took a while to set up the presentation at the presenter's site, I won't take any chances, and I will just thank everyone who has joined us, and I will hand this over to the host for this talk, Delaram, who's going to present our speaker. Thank you.
Thank you very much, Dimitar, for all the organization, and thank you all for joining this seminar. It's my great pleasure and honor to introduce Professor Awais Rashid from University of Bristol. Awais Rashid is a professor of cybersecurity at University of Bristol, where he heads the cybersecurity group and is director of EPSRC Center for Doctoral Training in Trust, Identity, Privacy, and Security in Large-Scale Infrastructures. His research interests are in security of cyber-physical systems, software security, and human factors. He leads projects as part of the UK Research Institute of on Trustworthy Industrial Control Systems and UK Research Institute on Science and Cybersecurity. He co-led the security and safety theme within the UK Hub on Cybersecurity of Internet of Things, and is a sector lead for the PETRAS National Center of Excellence in Cybersecurity of IoT. He leads a CyBOC, an international effort on developing a cybersecurity body of knowledge to provide interdisciplinary foundations for education and training programs, and is also a fellow of the Alan Turing Institute. So we appreciate very much that he provided this talk to us. And today he's going to speak about why Johnny doesn't write secure software. Thank you very much. So Awais, if you would like to start, we are ready.
I'm sorry, my microphone was on mute. Can you hear me now?
Yes, we could hear you very well. Thank you.
Okay, great. Okay, so thank you very much, Delaram and Dimitar, for inviting me and organizing this talk in the current circumstances. It's a pleasure to be here remotely. Just to get an idea from Dimitar, is it possible for people to kind of respond to questions, or as I go through the slides, because I have a couple in the slides, or shall we leave everything as if I'm just presenting?
So if anybody is very keen to ask a question, of course they can unmute their microphone and they can ask the question. I would suggest turning off the microphone afterwards, so we don't get extra noise.
And how long do you want me to speak for?
Since we're not paying you, you can speak for as long as you want.
No.
45 minutes would be ideal. Between 40 and 45 minutes, and then we can leave some time for questions.
Okay, so that's what I was aiming for. Okay.
Yeah. Okay.
So I'm going to talk about secure software development and the reasons that we've been investigating as to why software developers make mistakes in with regards to security in the software that they write. Before I speak about the work, I would like to acknowledge that, of course, this is work that is done in multiple projects. One is a EPSRC project by the same title, Why Johnny Doesn't Write Secure Software, and it is in collaboration with a number of colleagues. It's a long list, so I have not listed them up here. but they are acknowledged as authors and co-authors on the relevant papers, which are listed in the slides as we go through. So I'm of course grateful to my colleagues, because without our collaborative effort, this research wouldn't have been possible. And of course, to the funders, a part of the work comes from the funding by EPSRC and part from the National Cybersecurity Center. And we're always grateful for funders to support the work, which enables us to do this kind of research. So I'm going to start with these pictures. Anybody recognizes these vulnerabilities? Please feel free to shout out if you recognize them.
Heartbleed.
Mm-hmm. Anyone else? So Heartbleed is one.
There's a few things popped up in the chat. There's shell shock.
Yeah.
And then everyone's gone with Poodle.
Yes, of course. Yes. So it's Heartbleed, shell shock, and Poodle.
Oh, is it really Poodle? I thought I was making a joke.
Poodle. No, it is generally, the vulnerability is called Poodle, and it is a specific vulnerability in SSL v3, and which impacted a lot of the Alexa top 100 websites. And there was an interesting study on this actually, where once the vulnerability was fixed, this is an aside, a lot of the websites fixed it and then rolled back because it broke some of the services. The fix broke some of the services that they were actually offering. So security is never a zero-sum game in that sense. But yes, these are three of the kind of very well-known, widely known vulnerabilities that have impacted software. And the key, of course, is that software sits at the very heart of everything we do, in the infrastructures that we use, in the services that we utilize on a daily basis, from banking to shopping to our critical infrastructure environments such as water, power. They effectively run with software at the heart of them. And when we have these kind of large-scale vulnerabilities, they have a massive impact on the security of the infrastructure in itself, and particularly if you think about things like shell shock, then this vulnerability has existed for a long time, and it is in a piece of open source software which is often maintained by a small set of people, and although there is scrutiny, mistake can actually have a wide impact on the various software infrastructures, in this case operating systems, that utilized the bash shell. So this naturally sort of begs the question as to why developers make the mistakes that they do. So I'll sort of revert a little bit back to where the title of the work comes from. So it probably may or may not surprise you that today less than 0.1% of the email that we send is end-to-end encrypted. And there was a very interesting paper by Alma Witten and David Tygar back in the late 90s called Why Johnny Can't Encrypt. This was a usability evaluation of PGP at that time, and they highlighted how users struggled with using PGP, and its usability problems are quite well known. The interesting thing is that we are 20 years down the line from Witten and Tygar's paper, and we still have these problems with users being able to encrypt email. And the talk's title and actually the corresponding project's title comes as an homage to the original Witten and Tygar paper. It is not meant to imply, by the way, that programmers are always male. In fact, Johnny represents programmers of all diverse backgrounds and genders. It is just an homage to the original paper. At the same time, Ann Adams and Angela Sasa wrote their well-known paper, which was called Users Are Not the Enemy, where they talked about the challenges that users face. And we have all faced these challenges, having to change passwords, write complicated passwords, having to memorize them, and so on. And they did this wonderful study of highlighting how users are not necessarily trying to bypass security measures. It is just that the problems that they face, sometimes they don't understand the implications of those security measures, or they're just really simply trying to get the job done. And from there is this notion that comes is that normally the security approach tends to be is to fit the human to the task. So we tell people they must write complicated passwords or follow particular password policies. They must follow particular security hygiene practices. And all these require is to get the person to be fitted to the task rather than actually the other way around by fitting the task to the human so that it actually fits in with the way they work and the tasks that they want to accomplish. Okay, and from this principle that actually security has to be usable for the user, and we still are talking about the end user here, there are a number of things that we have to consider. So what do we need to do to make security usable? And there are a number of things that we should think about. When we talk about end users, we talk about effectiveness. Can users achieve their goals? So for example, you're trying to pay some bills online. You don't want security to keep on getting in the way, but you want to make sure that the transactions are secure. Efficiency. So what resources are expended by users to do so? Does it cost you a lot of effort to do it? So every time, for example, if you go away from your machine in a shared office and you have to lock the screen and come back and log back in, that is actually costing you time and effort. Okay. Or if you have to, for example, change your password and then rememorize a new password, it is also very, very time consuming. And I actually remember many years ago, a colleague of mine had come up with a perfect way of bypassing the university's password policy, because they had figured out that the password policy at that time required you to not choose one of the last 10 passwords. So they had a list of just the passwords that were useless that they would actually just sort of run through the system. So they actually never changed their password. But because the system didn't have the memory, it just allowed them to keep on using the same password, because they would just cycle through the 10 passwords at the time of password change and just put in the original password back again. And users come up with lots of ways to kind of bypass so that they don't have to expend lots of resources to do so. And then finally, it is satisfaction. What is the level of comfort and acceptability for users? Does it cause a lot of discomfort and a lot of complications? A lot of us have used two-factor authentication, where now all of a sudden, in addition to sort of using your credentials, such as a password, you have to carry a fob, for example, as an additional thing, or you get a code onto your SMS messages, and then you have to now read from a screen and type it into the next screen and so on. And that is actually not comfortable. And many users find this very complicated. And in fact, there is a wonderful paper a couple of years ago about two-factor authentication, where one of the users says they brought in this horrible USB key fob things. That was really the user's sort of reaction to all of that. So, but today we are not talking about end users. All of this is kind of as a way of background that there is a whole body of work on usable security. But until very recently, people haven't really talked about developers. Okay, so the question we should naturally ask is, what about developers? How do developers actually struggle with using security features that we offer them? Okay, there are lots and lots of cryptographic APIs and cryptographic libraries that are out there. OpenSSL is kind of the most well-known of these, and the vulnerabilities that arise from misuse of OpenSSL are very, very well known. There was a paper back in 2012, which also showed how SSL certificate errors in Android apps actually led to large-scale vulnerabilities. It was worked by Sascha Fall's team in Germany, and also we keep on finding these kind of problems where actually the libraries have the features that need to be used or can be used to, say, secure communication or securely transmit and exchange data, but developers make the mistakes that they do, and as a result, that leads to a range of insecurities. So we set out to investigate as to why developers struggle with using security, or what are the problems that they face. So we went to Stack Overflow. And we looked at just under 2,500 Stack Overflow questions and answers. We looked at a lot of the key libraries that are out there. that you see on the screen. As you can see, by far the largest number of these related to OpenSSL, because that is the most well-known of these libraries and most widely used. But there were other libraries such as libsodium, NaCl, Java-based libraries, libraries for Python, and so on. And we then went through all these questions and answers to try and categorize as to what do they represent. Okay, so in a separate piece of work, we have looked at the sort of authenticity of answers and how users decide on them, but I won't talk about that today. Here we are simply saying when a question is posed and an answer is provided, what does that represent in terms of a challenge that a developer may be facing? So let's look at a few examples. Okay, so here is a question whereby someone is trying to use OpenSSL, and they have gone to the documentation for OpenSSL, but they actually cannot find the information that they are looking for in the documentation. So they go and post this on Stack Overflow. So here we have an example of where the documentation is missing, and while the developer actually wants to go and find the answer in the documentation from OpenSSL, they do not have the answer in the documentation, so they go out to the community to try and find the answer. Then we have the question where it's a question of being able to interpret when something goes wrong. And in this case, what the example here is that the developer has tried to do something, but then something has gone wrong, but they do not understand why it has gone wrong in the first instance. So they go on to Stack Overflow and they ask the question, what's gone wrong here? Can someone help me? We can then see another example here where someone is using PyCrypto and they have a particular use case in mind, but they don't know if the feature that is provided by PyCrypto, which is a Python library, would be useful for that. So they can't relate their use case to what the library offers. So they go on and they ask the question, should I be using this? Does it make sense from the wider community? There are also many cases where, for example, developers just simply lack the knowledge of cryptography. And again, we should bear in mind that similar to when we talk about end users using security, we are talking about the fact that end users are not security experts in the first instance. And there is the old cliche that technology is designed by computer scientists and engineers for people like themselves, rather than the wider population. And the whole sort of field of HCI tries to address these issues. And the same is also true of, for example, security libraries that developers are provided with. So the library developers typically develop libraries with their own mental models and their own thinking in place, and they don't necessarily consider that the end users of the libraries, in this case other developers, will not necessarily be security experts. And one of the biggest challenges that comes, for example, with regards to end-to-end secure communications is that often when you give developers a task where you ask them that they have to secure data in transmission, then their approach will be to actually encrypt the data and transmit it rather than actually securing the link in an end-to-end fashion. And it's this kind of lack of knowledge that comes into play. And here there is an example that someone is actually trying to use OpenSSL and trying to test some certificates, but they don't really know how to do that, and they go and they pose that question on Stack Overflow. There are other challenges. So developers, for example, may be used to using a different library, and then they move on to a new library that they have to utilize, and they try to transfer what they know from their previous use of the library onto this new library that they're using, but it doesn't really work. So in this case, they are taking a mental model that they have of a different library, and they think that the new library should work the same way, but it doesn't, because of course there may be differences in the way libraries are architected. There may be differences in the programming languages that they service, and so on. And the developers' conceptualization of how a particular cryptographic feature or security feature works in a library doesn't translate into this new library. And then there are lots of compatibility issues, which is what we saw in quite a few times. So people are trying to utilize a library, and it doesn't necessarily work with other libraries or other features that they have in their software, and it leads to incompatibilities or potentially even just really simply performance issues. Okay, so you are actually incorporating OpenSSL into your software, and it's basically slowing things down significantly because of some of the other things that you are utilizing. So these kind of compatibility issues come up quite frequently. And we saw also another interesting thing, which was quite a lot of build issues. So people really simply just struggled with building libraries and building their code to get it to work, depending on the different kinds of environments they were using, and there were quite a lot of these. Okay, so we looked at these nearly 2,500 issues that we gathered on Stack Overflow, and we come up with a map. Okay, and I can go into the details if anyone wants as to how we analyze these. We ran a thematic analysis and cross-checking of the categorizations and codes that we came up with. But you can see here that there are effectively 7 broad categories. So we see usage issues, and there are 2 types of these. One is that a developer has a particular use case in mind, okay, and they have identified a feature in a library, but they don't know if it would be suitable to the task at hand. So they go and ask the question, should I use this? The other is that they actually know what feature they want to use, but they don't really know how to do it. So they know that there is a perfect feature for their task, but they don't know how to use it. So they go and ask the question, well, this feature exists, but how should I use this? Okay. We already talked about things like build issues and performance issues. So these come from system level problems. There is also the developers at times just simply don't know what to do. Okay, and we talked about lack of knowledge on the one hand, where developers may not have the underlying cryptographic or security knowledge, and the vast majority of developers necessarily do not. But there is also passing the buck, where and we don't normally blame the user, but in this case we did see examples where the developer basically all the information is available. There are examples in the documentation of the library. All the stuff is very clearly described, but they just can't be bothered. Okay, so instead of going and actually reading the documentation and reading the examples, they basically just go onto Stack Overflow and pass the buck and get someone else to do their work for them. There is other things like not knowing if a library can do something. So it could be that a feature is unsupported and the developer just doesn't really know that it's unsupported. And I already gave you an example of borrowed mental models. There were quite a lot of sort of examples of missing information. So where, for example, documentation is missing, people were looking, for example, code. The documentation was there, but it wasn't clear enough. And then, of course, there were a number of sort of things that simply arose from developers finding programming a hard problem for what they were trying to do. There were issues of abstraction. So, for example, in their head, they were trying to potentially secure an end-to-end communication link, but the library requires them to set lots and lots of different configurations. So there is a wonderful paper by the group in TU Darmstadt at ICSI a few years ago, where they actually did this study of developers and found that it's actually really, really hard to do a fairly simple task of using some feature in a cryptographic library. You have to set a lot of different parameters. And it's because libraries like OpenSSL have been designed to service a wide range of use cases. And if you're trying to service a wide range of use cases, then you have to provide a lot of different features that different developers can actually utilize. But the very base feature, which you are trying to provide to the kind of very basic development tasks, it also becomes very, very complicated. So there are abstraction issues. There are issues where the developers actually don't understand what's gone wrong when they've used a feature, and there is simple API misuse. So they should be using a particular configuration setting, and they use an entirely different configuration setting because they just simply don't understand it. Okay, and then there are, of course, issues around space and time. So features may have been deprecated and developers don't really understand that they've been deprecated, or as I said earlier, there are compatibility issues. So very recently, about three years ago, Matthew Green and Matthew Smith, they wrote a paper as an homage to the original Ann Adams and Angela Sasa paper. And instead of saying users are not the enemy, they talked about developers not being the enemy and the need for more usable security APIs. And they looked at some literature, historical literature, and they synthesized 10 principles for usability of crypto APIs, specifically, rather than more generally security APIs. So these principles are, of course, abstraction. Okay, so they argue that cryptographic functionalities should be integrated into standard APIs so that regular developers do not have to interact with the cryptographic API in the first place. Okay, they have to be powerful, so they should be able to satisfy both security and non-security requirements. They should be comprehensible, so they should be easy to learn, even without cryptographic expertise. And there are libraries out there that even say, well, you know, we are going to try and make it so usable that you don't even need documentation. They should be ergonomic, so they should fit in with the way the developer actually wants to achieve the task. So here we are talking about, I want to encrypt this link end to end, rather than, you know, I want to use this particular cryptographic protocol with this particular configuration, and things like that. And they should be intuitive and easy to use, as I said, even without documentation. There are others, so they should be hard to misuse. So if you do incorrect use, it should lead to visible errors. That is not always the case at the moment. You can actually set configurations in libraries that should not be possible. Yet they are. They should be safe, so there should be defaults which should be safe and should be never ambiguous. So we talked about, you know, secure by default in the case of software, or even sort of cyber physical devices, where we say they should come with sort of, you know, default features that are always on, rather than, you know, the user having to set them. So this should be the case here as well. They should be testable. A lot of problems arise because people try to use OpenSSL or other such libraries in a testing mode and then put them in production setting while they're in the testing mode, including with self-signed certificates and so on, and that leads to all sorts of problems. So there should be clear testing modes available. Readability of code and being easy to read and maintain is quite important, because the maintainer is not always the original author of the code, and that it should be explained. So it should also be able to assist with and handle the end user interaction and provide error messages where possible when things fail at runtime. So these are the sort of Green and Smith principles. You know, a synthesis of what's out there in terms of literature regarding security APIs and their usability. What we did was we took our analysis of the 2,500 or so Stack Overflow questions, and we then analyzed as to where the libraries in question were seeing the problems that they were seeing, because they were not in alignment with the Green and Smith principles. So I assume that many of the audience may be familiar with the notion of code smells. So this comes from the field of software refactoring, where Martin Fowler came up with the idea that if you have to make changes to your code, and you will see certain smells that will indicate that your code is not actually well modularized. And to actually improve the modularity of your code and hence improve maintainability, you need to address the code smells. So one example is here on the screen, which is Fowler's shotgun surgery. The name really comes from shotgun notion that, you know, he says you whiff this every time when you make a kind of change. You have to make a lot of little changes to a lot of different classes. And when the changes are all over the place, they are hard to find and it's easy to miss an important change. Okay, and he calls this a shotgun surgery. So what we did was we took this notion of Fowler's code smells, and we asked ourselves the question: are there usability smells in the crypto libraries that arise and that are actually symptomatic of the problems that developers are facing. So by mapping those struggles of the developers to Green and Smith's 10 principles, we identified 4 usability smells in that sense. And the first one of these is it needs a super sleuth. Okay, so this is when documentation is missing, it's unclear, or there is a lack of example code pertaining to how to use the library. Okay, you see this smell quite significantly in the libraries in question. The other is that confusion reigns. Okay, so you can smell this when developers are designing and prototyping their programs, and they're trying to decide whether this is the right library to use or how to start using it. The third one is needing a postmortem. So the developer has used the library, but something has gone wrong. Either they have used the library incorrectly, or they're struggling to work out if it is an issue with the library itself. So if it is not very easy for you to understand what has gone wrong and it needs a postmortem, then there is, again, a usability problem. And finally, it doesn't play well with others. Okay, so this occurs when the library won't integrate with other libraries and build systems, or is just simply a resource hog, okay, without providing a clear explanation of why. So having done this work of sort of identifying that developers do struggle with usability issues, and these issues come from some of the kind of fundamental design considerations within the cryptographic libraries. We then ask the question as to what are the other things that actually impact security of the software that developers write. Okay, so we actually in this case thought that, okay, we've now looked at the code that developers are writing to some extent because of the struggles they're facing with regards to the code, and they pose these in their Stack Overflow questions. What is the kind of broader process around software development? Okay, and here we specifically focused on the kind of wide range of developers who develop mobile apps. The reason being that, again, they come from many different backgrounds. They are not always trained software engineers or software developers. Many are hobbyists. Many are just sort of writing applications from home and deploying them to the world at large. And we looked at the kind of overall process or the key steps that developers would go through before releasing code onto an app store. Okay, in itself, and of course there is the usual kind of process. You set up your way of working, so you may be using a particular IDE suitable to the particular mobile platform for which you're developing. You would write and test some code. Okay, you will come up against problems. Okay, so you would try to solve those problems. You would have to consider monetizing your app. So, for example, by paying for through direct payment or through ad libraries, and you would also have to consider things like licensing agreements that you may want to use. So we designed a study. This was an online study where we gave developers a series of questions and tasks. One was to set up an IDE where we asked them to select what would be the 3 features they would include in their IDE, and the top choice here is the one that sort of prioritizes security. But there are others that also sort of have a higher priority towards security, things like the bug spotter. We also gave them a fixing of source code task where there were 3 different things, and they could choose one to fix and prioritize. One was relating to security, where passwords were in clear text. One was a performance issue, and one was a readability issue. Similarly, we gave them a task asking how would they go about seeking help on a confusing API. So this was a card sort. We asked them, what would be the choice of priorities, whether they would read the API's official documentation first or go to Stack Overflow. And this is based on a piece of work that Yasmin HR and others did on highlighting that actually even people who searched in a task that they had randomly on the web did better than people who went to Stack Overflow to find the answers to the questions that they had posed. We also then asked them what would be their testing strategy. Would they actually do proper user testing, or publish it and then sort of fix on the basis of the user feedback? And this was again a card sort exercise. We also asked them how would they choose an advertisement SDK if they were monetizing it. So, whether they would look at the permissions, or whether they would just look at website ratings, or incorporate as many ad libraries as they can, which would of course mean that there is more likelihood of data leakage from via the libraries. And again, this is based on existing studies. And we also asked them what would be their consideration in terms of license agreement and so on, and especially looking at whether sort of they chose licensing clauses which prohibit reverse engineering or benchmarking, because that is a way of actually working against sort of providing security scrutiny of the software. So this is a very sort of quick overview of what happened in each of these tasks, and as you can see, that a large proportion of developers actually chose a non-security solution compared to a security solution. So they didn't prioritize security uniformly in many cases across the various tasks, particularly around seeking help and testing tasks. This was most marked. The more interesting view is this one, where we actually looked at the rationale that they provided. We asked them why they chose what they chose, and we looked at the rationale and analyzed whether it was a security rationale or not. Okay, and in only a very small number of cases, with the exception of the fixing of the source code task, most people did not choose a security solution with a security rationale. In a large number of cases, they actually chose a non-security solution despite having a security rationale. In a significant number of cases, but in the largest number of cases, they chose solutions without any security rationale. Okay, so we then analyzed their rationales. We looked at what they had said and analyzed, and we noted that those who had a security rationale for their security solutions, it was based on a number of factors. So things like, trust in other developers. They were keen to understand the importance of permissions. The key message currently from the cryptographic community is that people should not be rolling their own crypto. They should be using standard protocols and so on. And that message seems to be getting through. Many people actually talked about that. Many people talked about input sanitization. So again, things like Awais top 10 are getting through. People talked about the importance of static analysis, the importance of bug spotters, and not storing passwords in plain text. There were also cases where actually people did have a security rationale, but they went for a non-security solution. So their rationale, for example, that users shouldn't be deemed to be predictable, or don't test by yourself, or being careful with personal data, was spot on, but they actually didn't choose a security solution, which was surprising. And then there were some other rationales. There was no clear rationale provided. People just kind of gave a security solution saying, well, that seems like it. So we looked at a number of factors as to what actually impacts developers' choices with regards to security. So it was quite clear that developers care about their users. So they talked about things like, I don't want to put my users at risk with weird permissions. They prioritize based on how extortionate or evil the clauses would feel to them as a consumer. They also often didn't want to actually deal with others. So they wanted to actually solve the problem first before drawing upon others' time or expertise. It was very important for the developers to be in a flow. So they said that they wanted to be in a state of flow, and they wanted their environment to work comfortably, and they didn't want to have lots and lots of interruptions from plugins. So here we again see that problem of security potentially getting in the way, and also an easy path. Okay, so they were, like any user, they were quite keen to solve the simpler problem first, and the least complex block was their focus. So this was a study of 44 participants. We then did a larger survey. So we reached out to developers on the Android App Store and using a GDPR compliance service, we actually reached out to a large number of developers and asked them if they would be willing to participate in the survey. The hit rate was, of course, as you would expect on these things, quite low. We had just under 275 developers participate in the survey, and we asked them the same questions that we had sort of given to the task-based study, but these were just sort of like a scale kind of questions, and we asked them whether these are the things that impact your the security of your the code that you write. And again, similar to the task-based study, the code itself was rated quite highly. But all the other tasks, with the exception of the external SDKs, showed similar patterns as what we found in the task-based study. The difference with the external SDKs was probably likely because of our framing of the question, because here we framed it as external SDKs, and in the task-based study, we specifically talked about ad libraries. The discrepancy probably comes from there because external SDKs are much broader than just ad libraries, and that's something that we would have to consider. So what we take away from this is that actually very much when developers are working on the software that they work on, they primarily only think about security with regards to the code that they are writing, but the broader process of writing software, which has a big impact on the security of the resultant software, is not always and in many cases at the forefront of their mind as having an implication in terms of security, particularly with regards to testing or incorporation of external libraries, especially with regards to monetization or sources that they may go to for help. Related to that, we've just sort of recently a paper accepted where we looked at a large-scale study of how do people trust advice on Stack Overflow regarding security. And it was overwhelming that it was just surface-level features. So if your answer was detailed and if you looked like you knew what you were talking about, okay, it could have been the most insecure answer and people would choose it, compared to if your answer was short, but it was actually correct, people would not choose it. So people don't really reason about sort of deeper things underneath. It's just, where it looks like, and if it's quite clearly laid out, then they would follow the answer. So people don't necessarily think that sources of help can have an impact on the security of their software. So this has been accepted at ICSI. This was supposed to be presented at ICSI in South Korea earlier this month, but that is now postponed to July and will be online. But the paper is available publicly. So I return to the sort of very early sort of statement that I made with regards to users, that security has to be usable. There are these three things: effectiveness, can users achieve their goals; efficiency, what resources are expended by users to do so; and satisfaction, what is the level of comfort and acceptability for users. And the interesting thing is that all these apply if you just change the word from users to developers. And as designers of APIs and libraries, we should be asking the questions: can developers achieve their goals? What resources are expended by developers to do so? And what is the level of comfort and acceptability for developers? And if we think of the developers as end users of our software libraries, we will find interesting answers in terms of their usability. And similarly, we should also think about it in this terms, that we should not be fitting the developer to the task of implementing security in the software, but we should fit the task to the developer, providing them with tools and techniques and APIs that actually make their task of incorporating security into the software as seamless as possible. So in general, this work is part of a large sort of program of research that we are doing in collaboration with other colleagues. And ultimately, our sort of collective aim is that, we have security vulnerabilities on this kind of, we can visualize this kind of as this kind of 3D visual concept. And we've got security vulnerabilities on the x-axis. We have human behaviors on the y-axis, and we have interventions to help reduce the number of vulnerabilities with regards to developers' behaviors that arise and manifest in the software. And ultimately, as a research community, our goal is to populate as many points in this space that give us the right kind of interventions to help developers achieve the task of security and reduce the number of vulnerabilities in the software that we have. Our research team and collaborations and hopefully others will work on populating this. So I think I'm just within 40 minutes, so I'm going to stop now and happy to take some questions.
Thank you very much, Awais, for this amazing. Are there any questions?
I have a question,
Yes,
if I
sure.
may. First of all, thank you very much for the talk. It was very, very nice. My question is kind of, I think much of the security software, like I think OpenSSL is written in C. Many libraries are written in C, and they are often also like very old code. And I think in the last 10, 20 years, we got a lot smarter. And for example, programming in modern C++ is much, much, much safer than programming in C. And the tools like the static checking and everything have also gotten much better. What do you, like from a security person view, think about this problem that so much is written in C, and why are people not moving to modern C++ to make everything much safer?
So I think if we are talking about sort of modern languages, then I think we have to go even further and talk about sort of more memory safe languages like Java and Rust and so on. You are right that the part of the problem is that OpenSSL is written in C, but the security problems in itself with OpenSSL are maybe due to the sort of the usage of C, but it's actually the struggles that developers face when they use OpenSSL is not necessarily just because it's written in C. It's just the way the API is architected and the complexity of using it, and you generally have to sort of twist yourself in knots to actually get a fairly simple function to work, and even sort of very, very strong developers with lots of expertise can't always be sure that they have actually used the library correctly. Okay, and that's really where the challenge lies. So we are not giving the developers the tools. And we saw similar issues with, for example, Bouncy Castle, which is a Java library. I always forget which one is which way around. So NaCl or Libsodium, I think one of them is supposed to be the more usable version of the other. I think it probably is Libsodium if I remember correctly. And again, we saw similar challenges. So the issue of developers struggling with implementing security in their software by using these APIs is not only a factor of them being written in C. And of course, a lot of people use OpenSSL because a lot of code is still written in C, and there are all sorts of reasons why they need to use a library at that level of abstraction. So there isn't a simple fix here, I'm afraid. The whole space is kind of very, very new. People have looked a lot at vulnerabilities that come from memory unsafe languages and how we can fix them, but people haven't looked enough at, to date at least, as to what are the features we offer developers and their interactions with the libraries and the problems that they arise as a result.
Okay, thank you very much. That's great. Thanks.
Thank you for the interesting talk, Awais. Nice to see you as well.
Hi, Radu.
I wanted to ask a quick question. So you showed us at the end this broad research space. I wanted to ask, is this covering the developers' understanding of security risk, or you perceive that as a separate area of study?
No, so I think the human behaviors dimension is very, very important from when we think of as developers, and how developers understand risk, and what their perception of this is quite a significant part of that. I think ultimately we need to understand all three dimensions, but we need to understand them also together, because it could well be that developers' perceptions of risks can be improved by giving them more guidance and things like that. But it could also be that if, for example, we give them checklists and they are just another painful thing to do, then they won't do them, and so on. And the fact of the matter is that your average developer wants to get the job done. Okay. They are under lots and lots of pressures. If they work in a large organization, they're under lots of pressure to get the code out, okay, and get the next release out, and meet other deadlines from customers. If you're a developer who is, for example, pushing applications out onto the on the App Store, there is a very interesting study, and I forget the exact figures, that a lot of the developers who are developing for large sort of mobile app platforms, they are young, self-employed. And effectively, if you look at what they make from their apps, are living below the poverty line. Okay, because they struggle to even get people to pay $1 for their app. Okay, so your then natural reaction is, can I incorporate as many libraries as I can, because I'll actually at least get ad revenue? But of course, then there is a huge variation in libraries that would ask for the minimal permissions to the libraries that will ask for everything, because that they are genuinely malicious in that sense. So no, that is a fundamentally important part. But I also firmly believe that we have to look at it with other things, like what are the specific vulnerabilities that arise, and whether some interventions make more or less of a difference.
Right, so that fits on the behavior on
yes,
your
absolutely.
Map. Right,
yeah,
thank you.
and there are a number of people who are looking at that. So yeah.
Are there any other questions?
Can I ask a question?
Yeah, sure.
Yeah, thanks, Awais. You talked about this interesting study that you did by sort of observing Stack Overflow. Just wanted to ask you to comment on two things. One, are there any limitations to that method of studying that research problem? And secondly, how to what extent that method can be automated, so that, for example, if I'm a developer of a security library, there is a tool that is able to observe Stack Overflow and give me feedback on sort of what I can improve in terms of my documentation or in terms of my architecture.
So I think in terms of limitations, what we did on Stack Overflow is effectively what you would call a qualitative study. We don't generalize from it. It shows us the issues that we see in the population of questions and answers that we saw. But I would argue that it's symptomatic of the problems that we see in terms of library usage, and it relates to some of the other studies that people have done elsewhere on, for example, Java APIs and so on, crypto APIs. They show kind of similar patterns. So I think yes, larger studies would need to be done before we even talk about the fact that this is a definitive categorization of the problems that people face. In terms of automation, that is a very interesting point, because that is certainly feasible. Because if there is a lot of work in sort of the broader software engineering literature, and it's not something that I do personally, but people have previously looked at, for example, mining user comments on app stores and using them as a way to identify where fixes need to be applied. And there is no reason why you can't deploy a similar kind of thing on a platform like Stack Overflow. Now, I know that Stack Overflow sort of actively sort of discourage harvesting of information in that way. But if it were actually built in as a feature into Stack Overflow, then trigger points or highlighting particular issues, and if we had some kind of a categorization, then it would be quite a useful way for API developers to get feedback on the improving the usability of their APIs. So I think that is certainly feasible as a mechanism, and it would be actually quite interesting to deploy something like that and see if it actually works. So yeah.
Thank you very much.
Okay.
Can you comment on specifically on the method that you have used and how, to what extent your method would be automated?
Sorry, the method that in this kind of 2,500 questions.
Yes.
This was all by hand. So
Nikhil
is my PhD student, and he actually collected all the questions that related to, and then we cross-checked it, and then he read all the questions and answers. We then went and checked all the libraries and the documentation to see. So it was a very, very resource-intensive and a manual-heavy effort, simply because we didn't want to misinterpret anything. Now, because we have this categorization, it's not so complicated, given that you can train a classifier. There is sort of fairly simple part of speech or natural language analysis tools that you can deploy to do something like that. But we haven't done that. This was all manual. So.
Okay. Thank you.
Yeah. Very committed PhD students.
Thank you very much, Awais, for the lovely talk.
Okay. Thank you. Thank you for having me.
And thank you. So, so if there's no other questions, so let's thank Awais, maybe in the chat, or if you want to say something.
Oh, you can turn on your microphone
Stay safe.
and then say thank you.
Thank you.
Thank you. Thank you very much.
All right. Okay. Thank you very much, and have a good day. And thanks again for having me.
That was great.
Stay safe.
All right. Okay.
Bye.
Bye. Bye.
Bye.
It wasn't very trouble. I